Principles of Microeconomics, Chapter 7, Production Cost and Industry Structure. Professor Wagner. The outline for this chapter basically refers to explicit and implicit cost, accounting and economic profit. It talks about production in the short run and in the long run, and the same with costs. The Amazon business model speaks to the economies of scale. They really kept their overhead costs down in terms of having brick and mortar stores, and they sell all manner of things through all manner of retailers. But their big success has a lot to do with its production model, particularly its logistics model. And so they've been able to undercut, competitor prices because of, let's say, their ability to what we call CRM or customer resource management, techniques. We speak to the theory of the firm. Firm is an organization that combines inputs of labor, capital, land, and raw or finished component materials to produce outputs. So, really simplistic examples of that would be, let's say, Ford or GM. Both companies are in the auto production business, and so they deal with all these components. Currently, they've been asked to produce respirators in place of cars because of the COVID crisis. So it's a way of repurposing the factory, but still the fact remains that it's a firm. Private enterprise is the ownership of businesses by private individuals. So we're talking about businesses being sole proprietors, or perhaps a partnership or a subchapter S corporation. Anything that is a subchapter C corporation, which has stock involved, may or may not be private, but could be also public. In production, the process of putting in, goods and processed, and ideally a greater value of the input. So basically, the sum of the inputs should come up with something greater than the value of what was put in. There are a number of competitive situations. Perfect competition. All firms are trying to sell the identical product, and that has a specific economic consequence. Another extreme is monopoly, where only one firm is selling the product, and this firm faces no competition. So we can think to, let's say, a company like Mylan. It's a pharma company and had an EpiPen that was probably could be made for about $10, sell for $30 with a 300% profit, and people probably wouldn't groan or complain. However, the gentleman that bought the company had a total, let's say, monopoly on that given product, and they were selling for $600, faces no competition. So this could be the result of what a monopoly does. They can set the price because, the demand is there and there's no other supply. Monopolistic competition is a situation where many firms are selling similar but not identical products. Let's say car companies could fit into that. So let's say you have Dodge, Chevy, Ford, Chrysler, and many others. That would be considered monopolistic. That could be considered, similar but not identical products. Oligopoly is a situation where a few firms sell identical and similar products. When we refer to the Russian oligarchs, they are the people that, it's like a consortium of individuals that really control all the resources, and they have tremendous sway in terms of supply and demand and cost. Here we have several formulas dealing with explicit and implicit cost. And so profit is simply total revenue minus total cost. Total revenue is created by price times the quantity sold, so that's revenues. Out-of-pocket cost, actual payments, wages, rents, cost of equipment, you name it, electricity would be considered explicit cost. Implicit cost is the opportunity cost of using resources the firm already owns. And so that could be the depreciation of goods, materials, and equipment. That's typically falls under an accounting function. Here you'll notice that accounting profit's a little bit different than total profit. We take the total revenue and we subtract the explicit cost. Economic profit, however, includes both the explicit and implicit costs. So economic profit is total revenue minus the total cost. And total cost is the summation of explicit and implicit cost. Production for a pizza requires a number of inputs and the tools and materials of cooking and serving. I think you can imagine many of these. It could be tomato sauce, it could be the mozzarella cheese that goes on the pizza, and other, assorted ingredients. You have to have a pizza oven, and really, a number of other items that makes this work. So we talk about the factors of productions, or rather inputs, and so these are listed. You have land, raw materials or natural resources, labor, capital, technology, and entrepreneurship. And then there's a production function. It's a mathematical equation that tells us Q can produce, Q, an amount of output, which is quantity, that a firm can do with the given amounts of the inputs. You got fixed inputs and you have variable inputs. So fixed inputs could be, let's say, the lease on a production machine, and it's the same cost every month and it's factored in. Rent, those would be considered fixed inputs. Variable inputs could be, something like, well, if the demand for, let's say, pizzas is really strong, you're going to have more dough and whatnot, other products to make the pizzas. That can vary. There could be a shrinkage in demand for pizza for some reason or another. And then, so therefore, those inputs would vary and so lessen. There's a shorthand form for production function. Short run, it's a period of time which at least some of the factors are fixed. A long run, everything's variable. Something you might want to remember the test. And so they talk more about the short run production. And so their example is an example of lumberjacks using a two-person saw. The output Q is also called total product, or the function of L and K, or just quantity equals total production. K is a fixed amount, and typically when you see K in just about any formula, that's considered a constant. And then the amount of trees cut down per day only depends on the amount of labor employed. So that's labor, and this is a constant. So quantity, total production is a function of labor. Marginal product, basically it's the additional output of one more worker. This formula could have a problem on the test. It's basically the change in total production versus the change in labor. That's what the delta is for. So you see a triangle, just like in science, chemistry, physics, they use the triangle, and that's a delta. Law of diminishing marginal productivity. Basically, if a firm employs more labor, eventually the amount of additional output produced declines. And that has a lot to do with the fact that you may have too many workers trying to put out a certain quantity of good. And so not everybody necessarily works at the same pace or as hard. So those are factors that would cause the law of diminishing marginal productivity to come into play. So we have the short run production function for trees. And the top graph shows the short run total product. And as the number of lumberjacks increase, the output also increases until we hit 5. And you notice there's a leveling off of the curve here. The bottom graph talks about the marginal product for trees. So the bottom graph shows as workers are added, the marginal product increases. And then as workers are added, it decreases rather quite significantly. But sooner or later, the MP will be increasing at first, but sooner or later, the additional workers will decrease marginal product. Here you have a general case for the total product curve, the marginal product curve. You might want to remember these shapes and be able to identify them. They'll probably be on a test. Cost in the short run have factor payments. This is a list: raw materials, rent, wages, salaries, interest, and dividends and profits. And then you have variable cost. The most typical is labor. Fixed cost are the cost of fixed inputs like rent, and these are the properties of it. So you may want to consider that test-wise. Total cost is simply the sum of the fixed and variable cost added together. So average total cost is total cost divided by the quantity of output produced. Marginal cost would be the change or the delta of the total cost, again, divided by the change of quantity produced. Average variable cost is divided by quantity of output. So this really could change, depending on the sample. Output affects total cost. At zero production, the fixed cost are 100. We're going to say that's at 160. But as it increases, variable costs are added to fixed costs. So the total cost is the sum of the two, and you can see that as as production output increases, so does the cost. Here we have several cost curves. You have the average total cost, and that's typically U-shaped. And so you'll see right here, this one here is U-shaped. The average variable cost lies below the average total cost curve and is also typically U-shaped, which would be ABC right here. And finally, you have the marginal cost, which generally slopes upward very, very quickly. Average profit. Okay, basically it's price minus average cost. If the market price is more than the average cost, the average profit will be positive, which is kind of very intuitive, and the opposite is also true. Very intuitive. In terms of long-term production, everything is variable, including capital. So the production function is basically the Q, the quantity is a function of the labor, and the constant of goods. Because all factors are variable, long-term production tends to show the most efficient way of producing at any level output because you have a chance to study it. Cost in the long run is basically a time where all costs are variable. And then production technologies, alternative methods of combining inputs to produce output. So you can effectively find the optimal way to produce, any given product. Economy of scale is basically in the quantity, of output goes up, the cost per unit goes down, simply because we've built in the efficiencies of studying the long-term trends. And so this is an illustration of economies of scale. And so at point S, the average cost of production is $12 per unit for 1,000. And as we move down this curve, this production curve, we go to 2,000, it's $8. When we go all the way out here to 5,000 units, it cost us $4. So this is an illustration of economy of scale. Shape of long-run cost curves. Long-run cost curve shows the lowest possible average cost of inputs, and the short-run cost curve shows the average total cost curve in the short run. And so here on a cost basis, cost per dollar, you have several short-run average cost curves. And so each one represents a different level of fixed cost, from the low level at this here, low level of fixed cost, to the high level of fixed cost here at SAR 5. Long run curve that shows the lowest for producing. Each quantity of output cost can vary. So basically it's the bottom edge of the family of cost curves. So you can see that the bottom edge exists here along this line. If a firm wished to produce quantity 3, it would choose fixed costs associated with this particular given cost curve. Here's quantity 3, and this would be the short run average cost to produce. Ranges on long run average cost curve. Constant returns to scale. So expanding all inputs proportionally does not change the average cost of production. There is also something called a diseconomy of scale, where the long-run average cost of producing each individual unit will increase as the total output increases. So a firm or a factory can grow so large that it becomes difficult to manage or run efficiently. So basically it turns into a situation where the right hand doesn't know what the left hand's doing, and maybe also due to its size, they have not factored in efficient, communications between departments and those other sorts of things. Communications would be the reason why this would not work so well. The size and number of firms in any given industry, well, that has an impact too. And so how many firms will compete, in an industry, whether firms in an industry have many different sizes, or if they tend to be the same size. So these are the things that influence the shape of long-run average cost curve. So here's a couple of LRAC curves. And so like anything else, there's a point where there is a clear minimus, and that's at $500 for an output of 10,000. And then on the other one, we have a flat curve. So basically anywhere from 5,000 to 20,000, the cost of production will be $500. Either one could exist. And so, there's, ways to calculate what the minimus of that curve is. Typically it involves calculus, but that's not something we're going to have to deal with in this course. This page is very similar to the previous page. For graph B, the low-cost firms will produce between output levels R and S. That makes sense. There's quite a variance on the amount of output they can do at that cost. It's kind of advantageous. So it can definitely compete, whereas this firm here has to operate on this curve. Well, he's really only competitive or effective in that marketplace at the point he can produce 10,000 and sell 10,000. Anything else, we'll put a crimp in the margin that he receives on the total profit. This concludes Chapter 7.